So we're moving into what probably is the longest amount of text you're going to have to go through. These chapters deal with wind, the motion of the atmosphere, vertical motion. They talk about how that relates to fronts. They talk about moisture and atmospheric stability. That's a lot of stuff. It's basically pulling in, though, a lot of what you've already learned. We've talked about wind already, also, but we haven't really talked about how that influences vertical motion. So I just wanted to give a bit of a look quick at an atmospheric surface weather map. We've learned how to read all of the wind's symbols. So if I'm looking at this here, notice how the winds are coming in this way, around this way. They're kind of flowing in a counterclockwise inward direction. Now, if I go around the big high here, they're kind of flowing out away from it. So that means we come in with the winds coming together in a low. They're coming together. They're pushing into each other. They can't go into the ground. So what are they going to do? They're going to rise. That's convergence. When winds push in together, they converge. Now, highs. Highs are the opposite. Winds are flowing clockwise around them and outwards. So if the winds are blowing out from the center of the high pressure system, then that means air from above the high is sinking down into it. So we have divergence at the surface and the winds are coming down. So there's your two main concepts for thinking about vertical motion. Divergence at the surface is going to tend to eliminate or reduce vertical motion. Convergence at the surface is going to increase vertical motion. And then, so how do we get this vertical motion to happen sometimes also? Well, we have things like fronts. Fronts are a slope in the atmosphere. Fronts are three-dimensional. So, for example, I have a cold front out here in Oregon and Washington State right now. On one side are in the 80s. On the other side, they're in the mid-60s, even low 60s. So if that air is colder, we learn. So what does that mean? If it's pushing towards the east, it means that warmer air is going to be forced to go up, rise up. It's going to lift. When it lifts, that's vertical motion. So a cold front is going to push up because it's denser, that warm air up above it. So you actually, if you were to fly across that front, fairly low level, you might actually go in, stay in the warm air a little while until you got into the cold air, even though you may be all the way over to Seattle. So that is an example of how the front slopes upwards. It would depend on your elevation and how steep the front is. Cold fronts are steeper because they're more dense air than warm fronts. Now, warm fronts, on the other hand, do trigger up a lift. They're pushing warm air ahead. They're lifting that cold air up and over them, but it's very gradual. It's going to be a long, slow slope. So that means that more stratus clouds, more general rain, covering a much larger area is going to occur with a warm front. Cold fronts are going to be more thunderstorms, strong vertical motion. So if you're flying into a cold front, expect to be bounced around a lot more than maybe if you're flying into a warm front or across it. So now we've talked about this, let's move on to just a few extra points here I want to make. And I want to show you with that, I want to talk about continuity of the wind. The atmosphere goes together as one big thing. In other words, here at upper levels is influencing what's happening at the surface. So if I have convergence that's occurring, say, up in the upper atmosphere, maybe 20,000 feet up. Well, if the winds are converging, that's going to push the air down towards the ground, probably going to cause the air at the surface to spread apart and diverge. Now, if at the same time I had the exact opposite occurring, and I had winds coming together at the ground, and diverging aloft, what's going to happen is the air is going to be rising up, taking its place aloft. That's how low pressure systems are going to be formed, you're going to learn. The air is being pulled together at the bottom or being torn apart at the top. Most likely it's starting out with divergence at loft. Understand these terms. Divergence, winds are pulling apart. Convergence, winds are coming together. Another aspect of continuity of the wind. Say I have a lake. We'll take Lake Erie, for example. I'm blowing a wind out of the northwest across Lake Erie. Well, there's not much friction, no really rough surfaces on the lake. So what is happening is the wind is picking up speed as it's coming across the lake. Now, northwest winds, I'm getting over to Erie, PA, or Cleveland, Ohio. All of a sudden, there's some hills there. It's a lot rougher. What is happening is that wind is slowing down. So if I have wind slowing down one part, accelerating coming into there, the air is getting piled up, it's converging, so it's going to tend to want to lift. That's why we wind up getting the snow showers in wintertime over the eastern part of the lakes where the winds are blowing from the northwest, typically across the lake. But you could get other things. I mean, I can get it here, for example, coming off the Atlantic Ocean right now. I have winds coming in from the Atlantic. We have lots of clouds today. Why do I have that? Because the winds are blowing nicely over the ocean. They're hitting the land. They're rising up. We're getting clouds. So that basic understanding of vertical motion is key here. Now I want to talk a little bit about moisture. All right. Moisture, water vapor, is the amount of water in the air. The more the pressure is in the water vapor, the more water is in the air. So, interestingly, really when we care about it is when it's saturated, right? If it's not saturated, you don't have clouds. Probably not going to be dealing with much ice on your aircraft. So you want to know a little bit about when it's saturated. Well, we have a chart here. And notice the saturation vapor pressure goes up as the temperature goes up. So warmer air can hold more water. More water vapor is in the warmer the air. In other words, in summertime, we have a lot more water in the air than I do in wintertime. Another key point, kind of interesting, that there's more saturation vapor pressure is higher when we have liquid. In other words, when we have super cooled water droplets in the atmosphere. So if we have that, the vapor pressure is higher around those water droplets and lower over ice crystals. That's going to become important here in a little bit. All right, another thing we just talked about. The temperatures rise, the relative humidity goes down because the warmer air can hold more water. That's why typically we have fog in the morning hours, because radiation fog occurs during the morning. If you go out into some of the valleys around West Virginia, look at them in the morning. There may be layers of fog all over the place in the valley. You go up to the top of the mountain, you don't have that, do you? Because it's above, all the cold air sunk. We know colder air is denser. It went down into the valley. So you wind up with all that wonderful cold air down there continuing to cool. Can't hold any more moisture. The relative humidity is rising all the way up to 100%. We get fog. When I worked in Charleston, West Virginia, I used to watch it form over the Elk River every night, it seemed like. And we could watch it rise up out of the river and out of the Kanawha River to an extent. And we would wait to see if it was going to reach the elevation of the airport. Some nights it did, and we would be socked in, very low clouds, almost zero visibility. And other days you can just see it get up just so far, and it wouldn't make it up to our elevation. Now, during the day, as soon as the sun came out, started heating the clouds, the relative humidity went down. We got rid of the fog. Aircraft could fly back and forth again. All right, there's one other part to this, and this may be the most complicated part of all. Stability. we need to understand stability because we talked about air rising because of convergence at the surface, divergence of loft, for example. Mountains, it hits a mountain and rises up it. Well, there's another factor here called stability. All right, think of a hot air balloon. That's what I like to think about anyways. Maybe you don't, but hot air balloons rise. So why do they rise? The hotter air inside the balloon is hotter than the air around it. So that means it's less dense and it's going to rise up. So if I have that, what I'm looking for when an air parcel of air, and that parcel could be any size you want to make it, is warmer than the air around it. As it's rising up, it's going to continue to accelerate upward because it is warmer than the surrounding air, and that air parcel accelerates just like a hot air balloon upwards. Now, once it gets the same temperature as the surrounding air, it's going to stop. And if that air parcel was actually colder than the surrounding air, well, then it's going to tend to sink back down. It wants to go downwards. It's more dense. So that is the key with stability. If the air is unstable, you're going to find the air motion, vertical motion of the air is going to increase. If the air is stable, it's going to tend to decrease it. So here are some lifting processes like convection. And here is where that warm air rises up in the warm, moist updrafts of the thunderstorm or the little cumulus cloud even. Gets to a point where it's cooled enough that it no longer is warmer than the surrounding air, and it begins to come back down and just makes a big loop. I used to think it was so neat. I would be flying into Orlando, and there was all these bubbly clouds, little cumulus clouds, maybe up to 5, 6, 10,000 feet at most. And once we hit them, we'd be bouncing like crazy in the aircraft. Why was that? Because you were in these up and down drafts. One part of the cloud was going up. When you got out of the cloud, the air was going back down. So the aircraft would just fluctuate with those clouds. We talked about frontal lifting, orographic lifting. Say you hit winds hitting the Appalachian Mountains, rising up the valleys, hitting the mountaintops and then coming down the other side. As the air is rising, it's cooling, right? Cool air can hold less moisture. Eventually, it's reaching what's called the lifting condensation level. Basically, that is air that's risen up to a point where it's reached saturation, whatever that temperature is for that air. And once it reaches saturation, clouds form. We already talked about precipitation and terminal velocity, and I wanted to just mention there are two different types of precipitation. Warm cloud form precipitation, where temperatures are above freezing in the cloud. You have little drops of rain, cloud droplets, kind of just hitting each other and growing in size. They do it through what they call collision coalescence, and they eventually drop down and it rains. Most of the time, that's not the case. Why? Because air gets cold. We finally get some ice in that air. Well, we know that ice, saturation vapor pressure, is lower than that over water. So all that moisture in the vapor around the water droplets is heading towards the ice crystals. The ice crystals grow at the expense of the water droplets, get big enough, and they fall down as snow. So almost all precipitation in our latitude starts out as snow. Why doesn't it stay snow? Well, the air gets warm as we're going down lower in the atmosphere. So it'll melt that. It'll become rain. Now, say you had a warm front that you were pushing through your area. We know the warm air is coming aloft, but it probably hasn't reached down to the ground yet. You're still in the cold air. That front's still south of you. Well, if it's cold enough and deep enough cold layer there, you're going to get sleet, frozen ice. If, for example, you had just a very little bit of that warm air get in, maybe it would stay all snow. Or maybe you had a lot of warm air above you, but right near the ground, the lowest 500,000 feet, are all below freezing. You get ice, which is what I hate. But and it affects your aircraft. You've got to think about that when you're flying. If you're flying above a warm front, maybe you're in the warm air, you got all this rain, wonderful. However, maybe you get a little bit further into the cold air and all of a sudden you're starting to get icing. So you've got to understand that and how that front is working. That is really what I wanted to cover today. I hope you got something out of that. Let me know if you have any questions. And because of this, you're going to have a test in 2 weeks. So please don't hesitate to ask.